Hello everyone, it's me Manisha Shrestha here presenting the video presentation on maths. Here I am going to discuss three questions with its solution. The first question is from application of differential equation in engineering field. The first question goes like this. A circular column of variable section supports a dead load P. The mean compressive stress of any horizontal section has the constant value and the material of construction weights W per unit volume. If the column has a radius x at depth y from the top, prove that pi fx square equals to p e to the power wy by f. Now, first of all, we suppose x as the radius of the section of the column at the depth y from the top. Then we consider equilibrium of an elementary slice of the column of the thickness del y. It is acted by the compressive forces as given below. These are the compressive forces. Over here you can see F1 equals to pi x square f, F2 equals to pi x plus del x whole square f, and its own weight F3 equals to pi x square del y w. You can see these forces. Here you can see the diagrammatic representation of those forces, dead load P, depth, and etc. For the equilibrium of the element, we have F1 minus F2 plus F3 equals to 0. We substitute the value of F1, F2 and F3 over here. This expression you can see in the diagram. F1 is acting downward and F3 is acting downward and F2 is acting opposite direction. So this expression is like this. Now substituting the values, we get this, and the further simplification, after the further simplification we get this. Now dividing both sides by del x and taking limit del x tends to 0, we get this. After further simplification we get this. Now which is the simple differential equation. Now separating the variables, we get w by f dy equals to 2 by x dx. Now integrating both sides. After integrating, we get w by f into y equals to 2 log x minus log c. W by f into y equals to log x square minus log c. W by f y equals to log x square. We get, and taking log into this side, we will get x square by c equals to e to the power wy by f. Then we get x square equals to c e to the power wy by f. If we assume r as the radius of the top section, so that when y equals to 0, x equals to r, we have the equation 1. From the equation 1, we have, when we substitute x as r and y equals to 0, we will get this. R square equals to c e to the power 0, and we get the value of c as r square. In addition, we use the fact that when y equals to 0, the compressive force is dead load P. We have P equals to pi r square F, and when we substitute the value of r square as C over here, we can see we get P equals to pi C F, and we get the value of C as P by pi F. Now from the equation 1, we get x square equals to P by pi F e to the power WF Wy by F. Then after we get, finally we get pi f x square equals to P e to the power Wy by F, which is our answer, which we have to prove. This is our proof. Now the second question is from general equation of conic section. Here we have to find the axis, tangent at the vertex, equation, and the length of latus rectum, and the coordinates of vertex, and the focus of the parabola given below. This is the equation of parabola, which is given 9x square minus 24xy plus 16y square minus 50x minus 100y plus 225 equals to 0. We further simplify this equation and modify into complete square. Then we introduce lambda over here. Here I have directly used the formula which I am going to show you. This is the formulas which I have used here. One of the formula I have used over here, you can see. Then I further simplify this equation and kept in this form. You can see here. Then choose the value of lambda such that the equation 2 and 3 becomes perpendicular, where the equation 2 and 3 are this and this. You can see here, this one is equation 2 and this whole is equation 3. Now we find the slope of equation 2, m2, as minus x coefficient by y coefficient. We get 3 by 4. And similarly we get slope m2, slope of equation 3, as m2 equals to 3 lambda plus 25 by 50 minus 4 lambda. These are the slopes. Here you can see, if equation 2 and 3 are perpendicular, we use the perpendicularity form, that is m1 by m2, m1 into m2 equals to minus 1. Now substituting the value of m1 and m2, we get the value of lambda over here. Now putting the value of lambda in equation 1, we will get the expression in this form, which is in the form Lx minus my plus n whole square equals to mx plus ly plus q. As the equation is in this form, we can use the formula this. You can see here, I have used this formula over here and substituted the values and simplified, and we get this equation. You can see here, which is the standard form, that is y square equals to 4ax. Now for the length of lattice rectum, we can see 4a equals to 20, this one, and we find the value of a also, a equals to 5. Now from that standard form, we can get the axis of parabola as 3x minus 4y plus 5 equals to 0, and also the equation of tangent at vertex as 4x plus 3y minus 10 equals to 0. Now for the vertex, we have to find the point of intersection of axis of parabola and tangent at the vertex. You can see here the equations, the equation of parabola, axis of parabola, the equation of tangent at the vertex, you can see here. And now by solving these two equations, we can get the value of x and y, which is our vertex. You can see the vertex equals to 1, 2. Here you can use different method of solving these equations. I have used this method. You can see here. Now for the equation of lattice rectum, we have x equals to a, where x is the equation of tangent at the vertex. Here you can see 4x plus 3y minus 10 equals to 5. Then we get 4x plus 3y minus 15 equals to 0 as equation of lattice rectum. Now for the focus, we have to find the point of intersection of axis and lattice rectum. The equation of axis is this and the lattice rectum is this, as given here. You can see. Now solving this equation, we get the value of x and y as focus. You can see here the focus is 9 by 5, 13 by 5, which is our answer. And the third question is again from the general equation of conic section. Here you can see the question. So that the conics represented by the equation given below is an ellipse. Also find its center. Equation refer to the center, equation of axes and length of axes, eccentricity, length of lattice rectum, foci, directrix. The equation of conic is this. Now we compare this equation with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. We get the value of a as 5, h as 3, b as 5, g as 6, f as 2 and c as minus 4. Then after we find the value of this. Here you can see, which is minus 192, which is not equals to 0. And for the checking, AB minus h square equals to 5 into 5 minus 3 whole square. We get 16, which is greater than 0. As we know that for the ellipse, for the conic to be ellipse, AB minus h square must be greater than 0, which is proved over here, and it is proved that the conic is an ellipse. Now we differentiate this equation first with respect to x and then with respect to y. Then we suppose this equation as 2 and this equation as 3. Now solving these two equation, we get the value of x and y, which is our center, that is minus 3 by 2 comma 1 by 2 equals to, we suppose it as alpha and beta. Now to find the equation with respect to center, shifting the origin to minus 3 by 2 comma 1 by 2 should be done. Then after we get the equations this. You can see here, the new equation is ax square plus 2hxy plus by square equals to this. You can see here. For this, comparing the equation this with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. And find this value as we have also done it before. We get this value as minus 192, and by the equation A, this one, by this equation we get this 5x square plus 6xy plus 5y square minus 1 is equals to minus 192 by minus 16, and which is 12. Okay, then before the simplify and we get this equation, which is the equation with respect to the center. Now comparing this equation with ax square plus 2hxy plus by square equals to 1, we get the value of a as 5 by 12, h as 1 by 4, and b as 5 by 12. Now to find the length of major axis and minor axis, that is r1 and r2, we have to use for this formula as 1 by r power 4 minus 1 by r square a plus b plus ab minus h square equals to 0. We substitute the value of a and b and h, we get this, and we finally get the value of r as root under 3 by root under 2 comma root under 6, which is the length of major axis r1 equals to root under 6 and the length of minor axis r2 equals to root under 3 by 2 root under 2. Now the equation of axes. For the equation of axes, the equation of major axis is given by this formula, a minus 1 by r1 square x plus hy equals to 0. We substitute the value of a, r1 and h, we will get this equation x plus y equals to 0, which is the equation of major axis. And for the equation of minor axis, we use this formula, a minus 1 by r2 square x plus hy equals to 0. Then we substitute the value of a, r2 and this h, we will get x minus y equals to 0. This is the equation of minor axis. Now for the eccentricity, we have r1 equals to root under 6, r2 equals to root under 3 by root under 2. Then we have the formula for eccentricity, that is r2 whole square minus r2 whole square equals to r1 square 1 minus eccentricity square. We substitute the value of r1 and r2, we will get eccentricity, which is root under 3 by 2. Now for the length of lattice rectum, we have the formula 2r2 square by r1 equals to this. We substitute the value and we get the length of lattice rectum as 3 by root under 6. For the foci, the equation of major axis is x plus y equals to 0. We find the slope of this major axis as minus x coefficient by y coefficient, that is tan theta equals to -1. Now, and we find the value of sin theta and cos theta over here. Sin theta as p by perpendicular by hypotenuse and cos theta as base by hypotenuse. By using this Pythagoras theorem, we find these values. Then for foci, we have to use this formula. That is alpha plus minus ER1 cos theta comma beta plus minus ER2 R1 sin theta over here, and we substitute these values of alpha ER1 cos theta. We get this. You can see here. Finally, for the equation of directrix, we get x minus, we use this formula, x minus alpha cos theta y minus beta sin theta equals to plus minus r1 by e. We substitute the value of alpha cos theta beta sin theta and we will get this. Substituting these values, we get this equation. Now by taking positive sign, we will get one equation, and taking negative sign, we will get another equation, which are the equation of directrix. And this is our final solutions. Now thank you for watching my video, and thank you for listening. Thank you.